Okay, next we are getting into CloudFormation, and CloudFormation here is not a service. You have to know in depth, but you need to understand how it works and its few features. So this is what I'm going to do in this lecture. So as we know, the CloudFormation is to bring the concept of infrastructure as code (IAC) into AWS. So the idea is that by writing your infrastructure as code, you can port it across multiple accounts and multiple regions. So you can reuse and quickly redeploy your infrastructure anywhere you want. Okay, so this is the backbone of the Elastic Beanstalk service also. Elastic Beanstalk service in the background spins up some very complex AWS CloudFormation template and actually provision your infrastructure. But also the service catalog service and the serverless application model framework. So the idea is that it's a low level tool that other services in AWS may rely on to perform their actions. Overall, it's a must know service when you are a developer, a sysops, a DevOps, or but for the solution architect professional exam, you still need to understand a few quirks. Okay, so let's go ahead with it and learn them. Number one is how CloudFormation works with auto scaling groups. So you need to know that the CloudFormation, when you create an auto scaling group with it, CloudFormation will only manage the auto scaling group configuration. It does not manage the underlying EC2 instances and that are in fact created by the auto scaling group. So what you can do through is like you can define success conditions when you are first creating your auto scaling group and your EC2 instances that come out of your auto scaling group, and this is called the creation policy. You can also define an update strategy for your EC2 instances, part of your auto scaling group by using an update policy. And so in case you have to update the underlying EC2 instances, you would have to create a new launch configuration or launch template. Then you would apply it to your auto scaling group by updating your CloudFormation template, and you would define an update policy on your auto scaling group to tell it how to update your underlying EC2 instances. So let's have an example of CloudFormation manages an auto scaling group that has two instances in V1. So, and we are going to update our CloudFormation template and create a new launch configuration or a new launch template. We are going to apply an update policy as well and in the CloudFormation template. And so this is going to force our auto scaling group to apply the new launch configuration and create EC2 instances. And then if everything goes well, then your EC2, then your auto scaling group would delete your V1 instances and would it shift to the V2 instances. Now, next, which is how to retain your data when your CloudFormation stack is deleted or like you are rolling back. So sometimes you don't want your resources in CloudFormation to be deleted because you want to retain that data, and by default everything gets deleted in CloudFormation. But you can define a deletion policy on any resource to control what happens when the CloudFormation template is deleted. So the first one that is extremely obvious is called the deletion policy, is called to retain. So in this case, you are specifying your rich resources you want to preserve or backup in case of CloudFormation deletes the stack. To keep a resource, you just specify retain, and it works on any resource or any nested stack. The second one applies to less resources, which is called the deletion policy. It's called to a snapshot. So in this case, we are saying, okay, you can delete the underlying resources, okay, but please make a snapshot before you do delete. So this applies to all the things that can be a snapshotted. So EBS volume, Elastic Cache cluster of Redis, Elastic Cache replication group, etc., etc. So it could be even the RDS DB instance, RDS DB cluster, or a Redshift cluster. So anything that can be a snapshotted, usually it's supported with deletion policy is called to a snapshot. So for CloudFormation. And then finally, the default behavior for most resources is deletion policy is called to delete, and that means that everything is deleted when you delete your CloudFormation stack. But there is an exception, if you are using an RDS DB cluster resources, the default policy is your snapshot. And if you want to delete an S3 bucket through CloudFormation, you need to make sure the bucket is going to be first entirely empty of all its content. Otherwise, you are going to get a failure. But from an exam perspective, remember you can set a deletion policy to control how CloudFormation deletes or not deletes the resources, even retains the resources and snapshot them before deleting them. Then we need to understand the security around the CloudFormation. So when you deploy a CloudFormation stack, and you have probably done that through the console once or even from the CLI. By default, it will use the permission of your own IAM principal. So that means that if you, as a user, are permitted to create, I would say, an RDS database, and you apply a CloudFormation stack that allows you to create an RDS database, then it would work. But if you, as a user, are not allowed to create an RDS database, but what you can do is assign an IAM role to the stack that can perform the actions of creating that RDS database. So there's two options. When you deploy a CloudFormation stack, either you use your own permission or you would assign a role to the CloudFormation stack, and that role will hopefully be able to perform all the things CloudFormation need to be doing. Okay, and finally, if you are creating IAM resources using CloudFormation, for example, if you are creating an IAM user, an IAM policy, an IAM group, this kind of things, then you need to explicitly provide a capability to the CloudFormation to do so, and that capability is called the capability underscore IAM or capability underscore named underscore IAM. Now next, CloudFormation can do custom resource using Lambda. Custom resources, CloudFormation can do custom resources using Lambda. So the custom resources help you address any of the following use cases. For example, AWS just released these new services, but it is not yet supported by CloudFormation. Or you have an on-premise resources that you would like to manage through CloudFormation, or you would like to embody an S3 bucket before deleting it. So, or you would like to get an AMI ID before applying it in your CloudFormation template, or really anything you want. Okay, so the idea is that these custom resources in CloudFormation is going to be backed by a Lambda function that you can create, and that Lambda function is going to be responsible for doing whatever you want in such of the cases. And it would be creating a new resource, or managing your on-premise resources, or importing your S3 bucket, all these kind of things. And so anytime you create, update, or delete your CloudFormation stack, then the Lambda function will be invoked, and that Lambda function we will do based on what CloudFormation tell it just happened. Okay, and the Lambda function you have to program will like do API calls, whatever you want to manage properly your custom resources. So the idea is, as soon as you need to get go a little bit crazy out of the box use of the CloudFormation, you have to use the custom resources with Lambda. Okay, next we have to understand the differences between the cross stacks references and the nested stacks in CloudFormation. Cross versus nested stacks in CloudFormation. Now this is online or something that people argue about a lot. So I'm just going to give you a one definition, and you can agree to disagree with me. But I think from an exam perspective, I'm going to be right here. So cross stacks is going to be very helpful when your stacks have different life cycles. That means you are going to have a VPC stack, and then you can have an application stack. So for this, for your application stack to reference, the VPC stack, you need to use exports and the function called import value. And so this is very helpful when you need to pass, for example, values from one stack to another. So if you are managing your entire network of the VPC through CloudFormation, and then you may want to retrieve the VPC ID as an exported value, in which case having a VPC stack and other stacks, for example, stack 1, stack 2, and stack 3, that reference the export value from your VPC stack, and it's a great strategy. Okay, the other option is to use nested stacks, and this is helpful when you have components that must be reused. So think like the module, for example. If you know how to properly configure an application load balancer, so this is something you may want to reuse across application stacks. So nested stack is only important to the higher level stacks. It's not shared. So here's an example I'm given. We have an application stack, and we have an application stack here, and we know we need to have an RDS stack and auto scaling groups, and the ELB stack. If you're not able to see that ELB stack is even here in this one. And each of these stacks is going to be independently configured, but configured well. And so the idea is that because we have nested stack, we can deploy a second version of our application stack, and that will in turn have its own nested stack for RDS, ASG, and elastic load balancer ELB. So we see in the cross stack way, we are reusing one stack centrally deployed, for example, your VPC into exported value for your other stacks. Whereas the nested stack, their modules, they are independent and they can be reused multiple times across multiple more parent stacks. So this is what's the nested stack and the cross stacks. Finally, for CloudFormation, there is a few keywords you need to know going into the exam. I don't want to deep dive on them, but the first one is CloudFormer. So CloudFormer is to create a CloudFormation template from existing AWS resources. So say like for example, you have manually created an EC2 instance, you have manually created a security group, and you want to make a CloudFormation template out of those. Then you would use something called CloudFormer change sets, which is to generate and preview the CloudFormation changes before they get applied. So in case you want to make sure that yes, the update I have coded in CloudFormation will do what I want to do, and then you would apply this change states to your actual changes. So then we have the stack states, which is to deploy a CloudFormation stack across multiple accounts and regions. And this is very helpful when you have, for example, an AWS organization and you want to deploy a stack across all your accounts to manage. And I don't know, like the configuration of CloudTrail, for example. So, and finally, we have stack policies. So, and these are the very helpful only to prevent accidental updates or deletes to stack resources. For example, you are using, hey, I have a stack policy, and that you can never ever change my RDS database because it's too critical. It's like production RDS database, and so that it gives you that additional safety, so that people, even if they modify the CloudFormation stack, they will retrieve an error from CloudFormation saying, hey, there's a stack policy in place that doesn't allow you to change this RDS database. Okay, so there is this one tip I need you to know, that this is integration of secrets manager and CloudFormation. So here where the template is, so in this first part of the template, we generate a secret from secrets manager. In the second part of the template, you use a reference, a sub function to find that secret and pass it into your RDS database instance. Okay, so this is how you inject the secrets. The password is created into the instance of RDS, and then finally the last part is to create a secret target attachment to link the secrets to the RDS database instance. And therefore, when the secret rotates, so will the password in the RDS database will be also rotated. Okay, so okay, that's it for this lecture. And also, if you are learning the CloudFormation, you are good with the CloudFormation, there is one more service that the Terraform, that Terraform is also the similar as the CloudFormation. But the Terraform, what it gives there, it gives you the multi-cloud opportunity to deploy into even the GCP or the AWS or even the Azure. So it's Terraform is also IAC as of the CloudFormation, but CloudFormation is just native to AWS. But the Terraform you can deploy across multiple cloud providing organizations. So that's it for this lecture, and I hope you liked it. And I will see you in the next one.